here we want again to use the integral to give us an estimate for a sum. In this case, we want an upper bound. And so I'm looking at the sum 1 over n to the 1.1. And for now, I'm going to think that this converges, so I'm going to try to show that it has an upper bound. Well, let's see. The first term is, of course, 1 over 1. And in this picture, the term 1 over 1 corresponds to the value 1 and the base 1. The problem is that this function, 1 over t to the 1.1, is not bounded, is not well defined. Well, it is defined except for 0, but its integral is not bounded between 0 and 1. So I actually cannot use the integral as an upper bound for this term. However, starting at 2, the integral does give an upper bound. And so, in general, the integral from 1 to 2 gives an upper bound for the second term. So, if I take n going from 2 to infinity of 1 over n to the 1.1, that is bounded by, well, the first term, and then this integral, the integral between 1 and 2, gives an upper bound for the value at 2, and then the integral between 2 and 3 gives an upper bound for the value at 3, and the integral between 3 and 4 gives an upper bound for the value at 4, and the integral between 4 and 5 gives an upper bound for the value at 5, and the integral between 5 and 6 gives an upper bound for the value at 6, and so on. So this gives an upper bound for all the terms from the second one on. And now we can calculate that integral and see what we get. And so let's do that. And so the sum with n going from 1 to infinity of 1 over n to the n plus 1, the first term is 1. And then from the second term on, the terms are bounded by the integral from 1 to 2, 2 to 3, etc. And this integral is t to the minus 1.1. So its antiderivative is t to the minus 0.1. I need a minus 10 so that when I differentiate this, minus 1/10 times minus 10 is 1. And the upper endpoint I'm going to call k, which goes to infinity, and the lower endpoint is 1. And so we have the limit as k goes to infinity of minus 10k to the minus 0.1, and then minus minus is plus 10, 1 to the minus 0.1 is 1. So this is what I have. As k goes to infinity, k to the minus 0.1 is 1 over the 10th root of k. That goes to 0. And so I'm left with 10 plus the first term, which was 1. And so the total is 11. And so I know that this sum is in fact bounded and therefore converges to something because the terms are, of course, positive. And so the partial sums are bounded, and this sum, this series, converges to something. I don't know what. I know it's something bigger than 1 and less than 11.